So I think that now, since we have arrived to an understanding of arrays, I'm gonna make this back a 12 again and just read that so that you can see it's whatever we expected it to be actually. So now that we have actually seen arrays of numbers, I'm gonna go to arrays of characters, and we're gonna talk about strings more specifically. So I'm changing that to being a character array, and let's keep it still at 12, and then let's write hello world again. So I'm gonna just write hello world here, and let's remove the size, not necessarily, from here. So I've got 12 elements, and let's now go and print them. So of course, made a mistake here. I want to print them as a %c, as a character. Yeah. Gonna print each one of them as a character, and that's what it looks like in memory. But what you really want to do is you want to, of course, try and read them really nicely. So just what you want really is a printf statement, and then you want a %c because that's a character, and then you go a count because you want all the elements of the array. So that's what's gonna actually print it really nicely for us. So if I put that here, yes, indeed, it prints hello world. Now here's the thing. If I was to get rid of this statement here, so I'm actually copying it. Let's comment this one out so it doesn't really work at all. And actually what I could do, just about do, is I could do this. Let's create a string and say hello world. And actually this should be quite happily able to read this and produce the same result. And what do you know? It has done just as I said. So that's quite interesting, quite nice. It is then therefore possible to initialize an array of characters as a string, and C is going to remember, C is going to effectively parse those characters and put them into memory for us. Now there's a bit of a method to the madness because I've kept this one here. What I wanted to do is I wanted to see exactly what is in all of those memory locations. So let's have a look now, and let's run this and see what's in all of those memory locations. And as you can see, again, exactly as we expected. Well, actually, it's been messed up because it's actually printed hello world at the end of every single one of our letters. Let's try and fix that. Let's get rid of that. I want to examine our memory locations again, so you can see the memory locations again. They are here. Now, that's all nice and well. Let's see if we wanted to read the first 13 elements of the array. Let's see what the last element of the array will be. Well, the last element of the array doesn't appear to be anything. There appears to be a gap here. Yeah? It's a gap if you print it as a character because it's actually non-printable character. Remember, we haven't put anything here, but actually it is the non-printable character that we're finding there. It is a non-printable character that we're finding there. And if I change that to %x, so it prints everything in hexadecimal, we will find out this is a 0 in hex. Let's try and look at it as a decimal. As a decimal, we will find it is a 0 as well. Okay. So now, what's that 0? That's a bit mysterious. That's a bit interesting as well, because it is not. Well, as far as we're concerned, we might as well be reading an empty memory location. However, actually, this is not an array of 12 elements. This is actually an array of 13 elements. Okay, and the last element is something called the null terminating character. So if I bring up a nice little browser window, and we say here null, so let's take an ASCII character, the ASCII characters, and let's go and see what 0 is actually. Oh, it's not cool. 0 according to this table here says null. Okay, now null is a very interesting character, is a very interesting construct. So before I go any further, I'd like to take you back here and say, okay, we have actually seen that the end of our array, which is 13 characters long, it's not 12 characters long, it's 13 characters long. It has as an end, the end that has been here is it's automatically put the null terminating character at the end of this array. The C programming language has put the null terminating character after the exclamation mark and before we close our string effectively, and this is because the C programming language, every time it sees a string and it automatically understands that it is a string, basically it will come here, it will see, oh, it will say, oh, that's a string. Okay, so what I will do is I will write all the elements of this string. Each element, I will put it into an element of the array, so it's going to be 12 elements. And then I'm going to create a 13th element, and I'm going to put the null terminating character in that 13th element. And you might say, okay, that sounds like nonsense, because why would C actually why would it bother doing that? Well, it turns out it is possible to do this. So you know how we have the printf statements? Well, it is possible to actually write your printf statement with a %s for string instead of %d or %c, which is what we've used. So if I put a %s here and then I give it the name of the array A, that is going to actually print the whole thing for us. So again, let's comment that, and this should actually print hello world on my screen if I'm right. And there you go. You can see it. It's printed hello world. Now, okay, but still we haven't demystified the fact that why would it put the null terminating character automatically at the end of the array? It just so happens that the printf function, when it's operating with the modifier of %s, it's going to read every single element of the array and print every single element of the array as a character, one after the other consecutively, just like a string, just like it looks here. And what it is going to do is it's going to look for the null terminating character. When it finds the null terminating character, then it knows that the array that it's trying to read has effectively finished. Okay? So basically, the null terminating character in every string in the C programming language exists in order to tell the printf function and other such functions, it exists to tell them that this is the end of the string effectively. In fact, if I was to remove that and bring that back up, Okay, so in here I have explicitly specified the array, so if I'm right, something should go horribly wrong somewhere here, because this one has not automatically created the null terminating character at the end of the array, so it should not work. And soon enough, what do you see? You see some strange behavior. Well, this has not worked at all well. It's printed some gibberish character at the end, which we do not understand, and it shouldn't have printed it. Yeah, it's because it didn't find the null terminating character. In fact, if I was to come back here and give it the null terminating character, I'll tell you actually the null terminating character, the way to write it is \0. If you want it to represent as a character, that's how it's written. So \0. So if I'm right, then this should actually come here and it will stop, because this the printf function is going to detect the null terminating character somewhere here, so it will stop. And as you can see, \ is a special command that tells it that this is not a printable character and it's a special thing. Okay, so it's the null terminating character. So if I run it, actually you can see, even though I tried to run the whole thing, once the printf function found the null terminating character, it just decided to stop, because it said, okay, that's the end of my string, that's the end of the string that I'm reading. So this is what happens basically. So whenever you tell C that you have a string, it automatically appends the null terminating character at the end of it, and this is what it did here, and this is what it does in this case, because it knows it is a string, because we have enclosed it in double quotation marks, and in C you enclose strings in double quotation marks while you enclose single characters in single quotation marks. Okay, so because it knows that's a string, it appended the null terminating character at the end of it, and because it appended the null terminating character at the end of it, instead of being 12 characters long, or well 12 elements long, this whole thing became 13 elements long, and then it saved it into the array. The size of the array was automatically adjusted to be 13 elements long, because we haven't put anything here, so it automatically adjusted it. And then when we try to print it, it works properly. Okay, as you can see here, yeah, it works really nicely. So this is a little bit about strings, effectively. Yeah, but there are other fun things you can actually do with strings. So for example, let's say we have a character array, we call it B, and let's say this one is 500 elements. I'm making this one quite big because we're actually not initializing it. And what we're going to do now is we're going to create a scanf statement. And then again, it's going to be a %s. And then in here, I'm going to tell it, okay, it's going to go to the address of B. Do you think this will work? Let's have a look. And then of course again, let's try and print B in a new line, just for good measure. See if that will happen. Excuse me, \n and then B. See if that will happen. I'm not sure. So again, hello world, and then it's asking me to type something. Okay, so I'm gonna, because this is now when the scanf function has been activated, so I'm gonna type in blah blah blah. I'm gonna type enter when this is sent into my computer, and then you can see here blah 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 is being printed out. So actually I have saved blah 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 inside the array called B, and then I've read the array called B effectively out, and well, this has now worked. Yeah, so it is possible to write somewhere it is possible to read a string from the keyboard and subsequently write into an array of predetermined size, and it is possible to read again from that array. Now, interestingly enough, if I did not tell to the C programming language the size of this array and I tried to run the same bit of code, it's going to freak out big time, it's going to give me an error, and it's going to tell me array size is missing in B. The reason why it says array size is missing, why does it complain about B and it doesn't complain about A, for example? Yeah, it does not complain about A, for example. Well, it does not complain about A because actually the size of the array A can be determined by the size of whatever it is that you're putting inside it. The compiler is clever enough effectively to figure out that this is going to be 13 characters, 13 bytes, so 12 characters plus the null terminating character effectively, and therefore your compiler, it is automatically adjusting the size here. So you cannot see it, but during the compilation process, effectively your compiler is writing the number 13 in there. Yeah, and this is how this works, and this is why it looks like you don't have to type it in. Well, basically, it is not that the processor is able to work with a dynamically adjustable array of no size, is that the compiler determines what the size of the array is and tells the processor what the size of the array is before the application is run. In this case, however, of course, we haven't initialized it to anything, so it tells us, oh, well, actually, you gotta tell us what the size is, otherwise, basically, I will freak out. So this is what happens here. So this is why I've put a relatively big size, so that it will take however many elements I want to put in there. Now, interestingly enough, it is fairly wasteful to do it this way, because basically I can type up to 500 characters, and then the computer is going to try and save those 500 characters. Okay? Actually, I cannot type up to 500 characters. I can type up to 499 characters, because the last character should be the null terminating character, because this is reading it as a string from the keyboard, and therefore it ends it with a null terminating character before it saves it in here. Interestingly enough, if I input less than 500 characters on my keyboard, the array is still going to commit 500 characters worth of space in the memory of the processor or the microcontroller or the computer, whatever I'm using. Okay, so I am pre-committing a lot of memory, and I may not fill it all. I may fill only part of it. This is fairly wasteful, but this is how it has to be done in the C programming language. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside.